All right, example 5, a word problem. So two rectangular lots are adjacent to each other. See the diagram. Write a function a of L of x for the area of the large lot. Okay, so let's take a look at that. So our larger lot here, well, a sub L of x, well, it's just going to be length times width. So that's going to be 4x times 2x minus 2. I think I'd prefer to simplify that now, because we're going to end up subtracting these. It's going to ask us for what the larger lot is, and we know what the total lot is of this. So it's not going to be a division where maybe I might leave these alone. So 8x squared minus 8x. So now it's in standard form. B, write a function a sub s of x for the area of the small lot. So a sub s of x, and then x times 3x minus 3. Again, I think it's probably better just to simplify this as much as possible. So we'll use the distributive property. Okay, C. If the large rectangular lot is 10 meters larger than the small lot, use a function operation to solve for x. Meaning, if I take my large lot and I subtract my smaller lot, then I should have 10 meters squared left over. Now we can substitute our equations into there. So we have 8x squared minus 8x minus, and that should be in brackets now, 3x squared minus 3x. And that's all going to equal 10. So we can combine like terms. So 8x squared minus 3x squared is 5x squared. And then negative 8x, well, that becomes plus. So plus 3 is minus 5x. And still equal to 10. Then I'm going to subtract 10 off of both sides. So we get to equal to 0. Now I'm going to factor this to find out what x could possibly be. But there's a GCF here of 5. So it's going to become x squared minus x minus 2 equal to 0. Now this factoring is a lot easier. So it's going to become x minus 2 and x plus 1 is 0. And therefore x is equal to 2 and negative 1. Now we're dealing with lengths, and I see one length specifically where it's just x by itself. So it cannot be negative 1. You should write that explicitly. It has to be positive. So therefore x is equal to 2. All right, finally, D. Determine the area of both lots. Okay, well, here we have 4x times 2x minus 2. So it's going to be 4 times 2 times 2 times 2 minus 2. So we're going to end up with 8 times 2, which is 16 meters squared. And then here we're going to have 2 times 3 times 2 minus 3. So we end up with 3 times 2 times 3, which is 6 meters squared. Now originally we were told this is 10 meters larger, and yes, that does hold in this case. Let's do one more word problem. So Greg wants to rent a stand at a flea market to sell old video game cartridges. He plans to acquire games for $4 each from an online auction site, then sell them for $12 each. The cost of renting the stand is $160 per day. So A, derive functions for the revenue, expenses, and profits of N. Okay, well, let's do A first. Our revenue first. So we've got revenue, R of N. And for every game, he is selling it for $12 per game. And then for my expenses, well, it cost me $4 to buy them. And then I also have $160 just to rent the stand. Now to find out what my profit is then, I'm going to go and I'm going to take my revenue and I'm going to subtract my expenses, and that's all related to N. So R minus E of N. And we want to figure out what that equation actually is. So we'll take our revenue, so 12N, and subtract 4N plus 160. So then we end up with 8N minus 160. Again, that minus there applies to both of these. Okay, B. What is Greg's profit if he sells 52 games? So we're going to do P of 52 then, equals to 8 times 52 minus 160. And we get $256 is his profit. C. How many games must Greg sell to break even? Okay, so here we want to know when P of n is equal to 0. So we're going to go 0 equals 8n minus 160. Add 160 to both sides and divide by 8. So we find that n is equal to 20. So it's going to be 20 games then.